All right, let's look at homework 6.6, problem number 10. I'm going to use the Geogebra to actually find the solution, right? But still, we need to set up the function by hand, right? So in this case, a is given to be 2, so this is 2, and b is 4, right? Then c is 6, right? So I'm going to call AP X, just like before, and PB, this is 4 minus X, right? So again, I'm going to split this angle theta into two parts, right? And the first part is theta 1, and the second part here is theta 2, right? So we have a theta, which is just the sum of theta 1 and theta 2, right? Right, since theta 2, theta 1 is same as this angle here, and theta 2 is same as there. So we can look at the tangent. So you can see that the tangent, maybe I'll write it here, tangent of theta 1 is opposite x over adjacent 6, right? So which is equivalent of saying theta 1 is equal to arctangent of x over 6, right? And the tangent of theta 2 is going to be, all right, so opposite is 4 minus x, to adjacent is 2, right? But we can rewrite it in terms of tangent. So theta 2, arctangent. So you have arctangent of 4 minus x over 6, right? So the theta we're looking at is simply just the sum of arctangent of x minus 6 and arctangent of 4 minus x over 6. All right. So let's put this in a GeoGebra. All right. So the function, I'm gonna call it f. All right. I'm gonna call it the f of x is equal to, or you can call it theta of x if you want. But this is arctangent, so in GeoGebra arctangent is a tan. So arctangent of x over 6 plus arctangent of 4 minus x over 2, right? Let's make sure, was it? And actually I messed it up, sorry. Since adjacent is actually 2, not 6. So 2 here, and this is 2 there. All right, sorry about that. All right, so let's bring the GeoGebra. So actually, I got this one correct. All right, so and then hit enter. All right, so we want to find the maximum here. So maximum is probably around there. So what you can do is we can actually take the derivative of that guy. So derivative, and see if f prime of x. Right? So it will look, it might take a little while, but it will give you, all right, so it looks like that. It looks actually pretty messy, but the thing we need is we want to see where its maximum. You can see that the maximum occur, and I'll erase this one, right? You can see that this is the critical number, so we're looking for that critical number. So I'm gonna actually stretch it out so that you can see it a little bit better. All right. So this is where the maximum is going to occur. So I'm going to use the intersect tool. Then I'm just going to choose this guy, and right. So you can see that, let's see, I have to change the rounding. All right, it's actually 1.110. All right, so let's type it in. So this is going to be, let's see, oops. So let's say 2 decimal places. It's 1.10. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. So all you really have to do is type in the function. So this is the theta function, and then take the derivative. And if you look at find the zero of the derivative, so that's going to be a critical number. And you can see that if you put this guy back in, oops, it's kind of hard to see, maybe bring it down. So you can see that the maximum occurs around this point, and where x value is about 1.1, right? So that's why answer is 1.10. Right? That's it. I hope that this was clear.